Perfect. And okay, cool. Thank you all for coming out tonight. As in the lovely introduction, Heather, Sullivan for hosting us, of course for sponsoring, as well as Temporal. I'm Peter Sullivan. I'm with Temporal. I want to chat with you all tonight about simple, reliable Sagas in TypeScript. Quick 2 seconds on me. I work for Temporal. I'm a solutions architect there, based here out of Chicago. A bunch of folks in the company are in Seattle, but we're fully remote, distributed. I've been in software development, architecture, security, the industry in general for 20 plus years now. Worked for a bunch of other companies, some national, some global, some local here in Chicago. And out on LinkedIn, as you might expect. Happy to connect with any and all of you there. A couple quick questions for you and your experience. How many folks here are building backend applications as opposed to? Awesome. So good segment of folks here. Working with transactional layers, storage, persistence, otherwise queuing, or you handling transaction management. Anybody familiar with the Saga pattern? You heard the term Saga before? Oh, awesome. All right, folks there. And then anyone using Temporal? All right, cool. So Temporal will be new for almost everybody. All right, so I'm going to start with just a simple business process, right? Imagine you're booking a trip, and there's 4 very simple steps in my hypothetical business process here. I'm keeping it simple for my application development or my team here, and that the booking of a trip requires doing 4 things in sequence: booking a flight, a hotel, a car, and then collecting payment for those things. If I'm going to sit down as a developer and imagine, for now, I'm not integrating with external flight or hotel or car booking services. We can swap those in later. But I'm just, I own all these things, and as soon as I, write my reservation to the database, that is the essence of the booking operation there. So I'm going to build something that we might traditionally refer to as a monolith, right? Or at least just start down and hacking away on my local desktop. I'm going to have my tripping application. It's going to have 4 functions in it to book a flight, a hotel, a car, a payment, and it's going to write those things to the database. And I can write those things to a database in a single transaction, right? I got one application working with one database, single node, single database. This is super simple programming model. We've all been using a database as a transactional data source for decades now. This is a little bit of a TypeScript. I think it's type ORM as an ORM layer for TypeScript or library. But it gives me the ability to interact with my database through that object relational mapping. And so I'm just within my transactional function to store all of these 4 operations after as they've been executed or as they need to be executed. I do that within the scope of a transaction. The transaction boundary is the beginning of this function. I code my intent to save my flight after I've created it to the database, the hotel, the car, and the payment, and I end the transaction. Now, we all know, based upon transactional semantics, if something goes wrong during this execution, our database gives us a lot for free, right? It's really cool in that if when I attempt to save that car, perhaps there's a business level condition why I couldn't book that car, race condition, it was out of stock, or the car was taken by somebody else, or wrong car ID or something in that, the database will automatically undo and roll back the previous steps that were intended to be done as part of this transaction, right? So we get, within the scope of a transaction, it is atomic, one of those classic ACID properties of databases, right? Our atomic operation, if any part of it fails, the whole thing is undone. And we don't have to write any code for that, right? Really simple programming model, and we're using modern databases, modern ORM libraries to implement our code that way. The challenge is we work in most often or often not in monolithic applications with a single database, but with microservices, many application components, many separate data stores, right? So in this case, I've broken out that book tripping application into 4 separate components. I have a flight service, which has its own database, a hotel, car, payment service, respectively, right? So each of those operations in terms of booking flight and booking hotel, car, and collecting payment are handled by different services. They're no longer communicating with the same database, and therefore I no longer have single transactional semantics across all 4 of those operations at the same time. I can execute step 1, in my application, and I can write my flight reservation to the database in a single transaction. But I have to do that independently in a second transaction for the hotel, a third transaction for the car, a fourth transaction for the payment, right? So we got four, now we're in the world of a classic distributed transaction. If something goes wrong again, right, and at step 3, we're unable to reserve that car, we're able to write that data or insert that into the database, at this point, what do we do, right? The database isn't there to help us anymore. We're not working with a single database. We have multiple components, distributed components at play here. How do we handle this scenario? It's now incumbent on us as developers, engineers to figure this out. And so that's where the Saga pattern comes in. The Saga pattern, now this is a lot of text. These slides are a lot of text, I apologize for it. But failure management pattern, right? It helps us establish consistency in distributed applications. So we're working with multiple components in our applications, and we're trying to handle the consistency of a transaction across them. It coordinates those transactions between those multiple services, microservices, again, around data consistency. Again, the Saga pattern is going to give us an approach for transaction management using a sequence of local transactions. What we saw here, right? These were 4 different local transactions rather than a single global transaction that we saw on the previous slide. And if a local transaction fails, Saga introduces a term for us and an approach to follow called compensating transactions. The compensating transaction is the thing that's going to undo the thing that has already been done. So we got that for free, again, in our first scenario where all 4 things were being done in a single database transaction to one database. Now we have to implement compensating transactions ourselves, and we can use the pattern to guide us along how we do this within our applications in a same way. So let's add compensations to our functionality. So now our flight service not only has an operation called book flight, but we code up a function called unbook flight. Probably more grammar there. I apologize for that. We could have chosen better words. Naming things is hard, but we're going to unbook a flight here. Hotel service has the canonical book hotel, which was our primary function, but we've introduced a new function to that service called unbook hotel. Car, unbook car, payment, refund payment. I think I got some naming on that last one. And so now, in the sequence of our events, our application can invoke book flight, it can invoke book hotel, it can invoke book car, and now we get that same failure. Right? I'm picking on the car service a lot in this presentation, but the car service introduces a failure, and now we can execute the compensating transactions to roll back. So at this point, now step 4 happens. We're actually going to call the unbook hotel function. And then we're going to call step 5 the unbook flight function. And we're going to return the state of our application to the pristine state it was in the beginning. That atomicity, right, that we talked about before. All of it happens or none of it happens, right? So we roll back. But in a distributed systems world, a lot of coding for us to do to make that happen. How do we coordinate the execution of these additional events now within our application, these additional functions? There's 2 primary methods and approaches that we can take. Choreography versus orchestration. The folks kind of debated those approaches within their backend development. Have you heard the terms of choreography versus orchestration? Okay, so there are 2 kind of parallel approaches, although they can be mix and match. But choreography is a decentralized approach where each service is responsible for reacting to events. It's part of an event-driven architecture, an event-driven approach to executing functions or within microservices within our environment. So each service is responsible for its own doing and responding to events. So things like book flight and unbook flight would be different events that the flight service would. Orchestration is a centralized approach where we introduce a 5th component, in this case, to our application. We build a central coordinator or a central orchestrator. And it is responsible for directing what happens, right? It is the one that knows that car service has failed in that matter, and it knows to ensure the correct order of execution of events or the undoing of those events to roll back those. There are benefits and disadvantages to both of these approaches. Right? So for choreography, it is seemingly manageable for simple flows. We have, again, these four services, but there's a lot of lines and queues, potentially message queues or those pipes in between them at play here. We're introducing additional architectural components, infrastructure components, and a lot of messaging flows between them. We're avoiding introducing another service, right? So we stick with the same 4 services that we first defined, and there's no single point of failure. right? Each of these services, flight, hotel, car, payment, operates independently. They're not, again, tightly coupled to anything else. They're not dependent upon anybody else. They're just listening for events and they're reacting to them. Did I receive an event to book a hotel? Yes, I'll do that. Did I receive an event to unbook a flight? Then the flight service will do that. This becomes very difficult to track, right? Insights, observability into what is happening with our applications are hard. Both from at design time when we're coding things and at runtime. So it may not be obvious, which services are reacting to which events, because some services just publishing an event out there for somebody to consume, somebody to listen to and react on. It's challenging to add new steps. If I wanted to add a service or a step sequentially in between hotel and car, I got to rewire the events that hotel publishes. I got to rewire the events that car service publishes. That new step now has to take on, maybe it's some sort of excursion package. It has to now publish its own events. We've got to modify the things that need to listen to it because it's participating in this Saga transaction. So there's another component at play. We do risk cyclic dependencies. Again, conceptually the cognitive load here can be hard. We may not fully understand as a developer, as an engineer, which services depend on which each others. Testing can be difficult, and again, monitoring and debugging can be challenging as well. An orchestration approach appears a bit simpler on paper, right? Fewer lines but there's an additional box here, so we're trading a box for some of those lines and pipes. It is better for complex workflows with many participants, kind of those dependencies and the exponential or addition of components in terms of drawing new lines and boxes is much reduced. So it's easier to add new participants. If I wanted to put, again, that excursion service between hotel and car, I drop that in there, and the only code that needs to change it lives within the orchestrate, right? I don't have to change the hotel service. I don't have to change the car service. They don't have to publish new events for somebody. We can very clearly avoid cyclic dependencies. And again, participants don't need to know about other participants. Hotel could care less that there is what comes after it is excursions versus car versus something else as part of our track. However, it does require a new component here. So we got to build this orchestrator. And so we got to implement that logic of that orchestrator. And then the orchestrator can become a single point of failure, right? So now it can crash. And what happens when the orchestrator crashes? Where are we at from a state of this overall transaction that we're trying to coordinate here with our Saga? So as you read and explore the Saga pattern on the internet, in the heavyweights of the industry, AWS, Azure are going to give great advice, guidance, patterns on using Saga, but also very critical and clear warnings, right? AWS's prescriptive guidance page on the Saga pattern says it's difficult to debug, it's complex, it has a complex programming model, right? In terms of designing these the compensating transactions and executing rollbacks and undoing changes. Azure is similar, right? Saga patterns are challenging, hard to debug, complex. You have to deal with potential transient failures, right? These are things that you need to code for as an engineer. You have to implement your own observability because it's hard to see and debug and understand what's going on with your transaction. And you're responsible now for thinking about reliability and durability challenges. What happens when these points of these things? And so that's where Temporal comes in. So Temporal is an open source platform and programming model for durable execution. And I'll explain more about what durable execution is if that's the first time you're hearing that term. And this applies equally to Sagas as well as other distributed components and the execution of business process and workflows across those distributed components in your environment. And Temporal is going to give us a lot of things for free. One is durability and reliability. It's going to handle a boatload of failures, transient failures, and issues that can happen within our applications, and give us a simple programming model to implement our business logic in, where we don't have to focus on those failures as heavily as we have in other frameworks or libraries. And so that's going to increase our developer velocity. And finally, it's going to give us insight. Temporal is going to act as an orchestrator. So in the choreography versus orchestration comparison, Temporal is on the orchestration side. It's going to be a central orchestrator where it's going to be capturing the events of all the things that are happening, and it's going to give us great insight into those things. So we're not wondering about which messages have been sent and which components have reacted to those messages and which functions have. Here's my architecture for that same trip booking application with Temporal. On the left-hand side is my app. This is what I write. Appears similar to that kind of monolithic picture I drew at the beginning, right? I have I can program as if I'm working writing code that's going to run on a single node with maybe a single database. And I can write my function sequentially, such as book, flight, hotel, car, collect, payment. Now, in the background or on the right-hand side, there is a critical service called the Temporal service, which is now going to be helping orchestrate and save state and manage the execution of this function. And so the function that we write, we code it using the Temporal SDK. And we'll see code in just a moment. So Temporal supports Python, Go, .NET, Java, and TypeScript, JavaScript. And of course, we're here for TypeScript, JavaScript. But ultimately, the Temporal service is taking all the hard parts of developing and working with distributed systems, leaving you the easy parts as a developer to just focus on your business logic. So in terms of the execution of a function, what does durable execution really mean? Well, so again, now let's consider something that is pretty close to TypeScript here. Don't know if it would compile, but it's in a slide. It doesn't need to. And so we have our book trip function, and we're going to call sequentially book flight, subfunction, hotel, car, collect, payment. Imagine, again, execution progresses on this node, on this laptop, on this server, to line 4 here of booking car. And at this point in time, the process crashes, right? It runs out of memory, it runs out of disk, whatever happens. Somebody pulls a power cable in a data center, who knows? But the process that this function was running on was died. Well, ultimately, we want this function to continue. We don't want it to repeat the steps of book flight and book hotel. We want to resume from where we left off. But with the simplicity of this code, we don't seemingly have any obvious logging, event handling, error handling that tells us where this function is. But if this function is executing as a temporal application, Temporal knows where this function is. Right? That's the magic of Temporal. Temporal has been tracking the execution of this function since it started. So Temporal, the server on the right-hand side, or at least the icon for the server, knows that book flight and book hotel have already happened. It knows that the failure before book car successfully executed. It resumes this function on a new node, on a new process. And then it continues that function on until it completes successfully. Right? So we don't repeat work that had already been done. We don't lose the state or context of work that had already been done. We rehydrate a second process. So durable execution for us is process execution, function execution can span process boundaries. Right? A function can start on one process, one machine. That machine can die. A second machine can be provisioned or be ready to go in an HA setup. And you can pick up this function and resume it exactly from where it failed and continue it on. Right? So we get this durability of our execution again. It's a pretty powerful concept where our functions now can span process boundaries. And so, we're used to normal execution where functions fail, when a process crashes, when something is killed by the operating system, machine loses power, transient failures, or just deploying new code. Maybe we just have a new rollout of our application version 2, and all of the processes that are handling transactions in flight, well, those processes die. What happens to those transactions in flight? Well, with Temporal, with durable execution, we're going to guarantee that those functions will resume, and they will complete running with consistency and correctness. So how does this apply to Sagas? Well, again, it allows us to greatly simplify the programming model. Temporal, again, is the orchestrator that is coordinating the execution of our activities. It is storing state. It is managing that persistence. And so we don't have to now build a state machine ourselves. We don't have to track execution of functions. In the most simplistic Saga that we can write in Temporal, you can imagine it as it just handling a try-catch, right? Or executing, the compensating activities within the catch clause of a try that catches a failure. So in this scenario, imagine book, flight, hotel, and car succeed, collect payment. For simplicity, I'm only putting a try catcher out in this block here, but this throws an error. We catch that error, and then we run the compensating activities of undo the flight, undo the hotel, and undo the car. And I probably should have done those in reverse order of car first, hotel second, flight third, but I'll fix that for the next slide presentation. So anyway, this is the most simplistic Saga we can write. Really avoids all of that pain and challenges. And we'll get to real code in a second. That'll be more elegant. But that Amazon and Microsoft from Azure were warning us about, right? The complexity of the programming model, the challenges of reliability, of durability, the need to handle failures, across a distributed set of services. So Temporal gives us or solves or helps us solve those problems. So let's jump into code and see this in the demo. And I'll just check the chat here. Acknowledgement from Pete, an emoji, thanks. And while I switch over to demo, just any initial questions around what I've chatted about so far?
How often do you use Azure?
How often did I use Azure? For me, a little, not much. I mean, our team has accounts on AWS and Google. So I use this.
You check your mistakes.
How do I?
You check your mistakes to save your libraries.
How do I just?
So, like you said, you go back and self-check your work, right? Self-check your work.
Like application code that I'm developing. Yeah. How do I? So Temporal is a. Right, so I'll step back closer to the mic. The question was related to how do we validate and check the code that we're writing. There was a question around Azure as a cloud environment. I'm going to make it cloud agnostic. Temporal is a cloud agnostic solution, right? So we're not tied to any one cloud. You can write and run your applications with the Temporal framework, library, the SDKs, and deploy and run anywhere you want. You can deploy it again on your laptop, run it on a physical machine, in a data center, run it on a virtual machine, run it in a Kubernetes cluster as a container or Docker container in a cloud. So the way the application behaves is the same across clouds. Of course, if I was deploying an application into production on Azure, I would test on Azure prior to going to production. I'm not deploying apps onto production, so Azure's not part of my daily lifecycle of work, but I use AWS and Google more so. The second question.
So in your example, you used it for like booking flights and stuff like that. But can you hear me?
No, I can't.
I'm sorry. In your example, you used the SDK for booking flights and stuff like that. But can it be used in different transactional processes, such as like gaming or that, or is it only limited to like booking flights?
Yeah. So the question is, what to genericize it? What are the use cases that you can leverage Temporal in your application development? Is it specific to things like travel booking, flight booking, etc.? And the answer is absolutely no. Right? It is a library that you can code anything you want with. Right? So I can have all kinds of business processes. We have folks that are using Temporal for payment processing, for loan origination, for Snapchat is one of our largest users of Snap, and all Snap stories are processed by temporal functions or temporal workflows, we call it. Any two steps of a business process that you want to simplify state management, that you want to increase reliability around, that you want guarantees around execution, are relevant for a temporal workflow.
Yes. How does Temporal know that a process or a node?
I'll show you that. Yeah, the question is, how does Temporal know how things are broken? We'll see that in the demo in just a second.
Can you use just imagine we have millions of records of data that we want to process. Can be Temporal used to distribute processing load amongst different nodes?
Absolutely, yeah. So the question was, if I have millions or more of processes, I was kind of skip this slide, but for Temporal, so that application that we write with Temporal, we kind of globally refer to it as a worker. A worker is what executes our workflow function, as you know, it is built with the Temporal SDK, and it executes these steps that we want to track the state and we want to durably execute. Those are infinitely horizontally scalable, right? So the same way I can approach microservices development and deploy independent functions and isolate teams and parts of this business process from each other, I can absolutely do with Temporal. Obviously I've given you the impression that this is kind of monolithic in nature, but that's not from a runtime perspective. Like what I'm trying to convey there is more like from a development perspective, I don't have to think about distribution, availability, or scale. I can think about it as if I'm just writing a local function, and Temporal will handle the hard parts about making sure that that's reliable, scalable, and operates in a distributed systems environment. All right, I'm going to move on to the demo, and we'll take more questions after the demo. So the first thing I'm going to do is I'm going to start my Temporal server. So as mentioned, in that other diagram, there's two primary components, right, to an application or temporal architecture. There's a temporal service on the back end, and then there's the application that we write. So Temporal provides a complete local development environment in the local server. So I'm going to fire that up. The next thing I'm going to do is I'm going to start my my TypeScript application. So this is the application that's going to run and effectively perform these functions here for trip booking. I want to quickly show the code for that. Temporal, there's the two primary primitives in Temporal are called the workflow function, and then there's activity functions. And so this is the top level function, like the main program, right, in a Temporal application, is your workflow function. And so that's what we're defining here on line 21. It's my my book workflow, my trip booking workflow. This is the function in which I'm going to write the logic of the steps that need to complete reliably and durably. And so these steps are, in sequence, book flight, book hotel, book car, all right, and continuity error. I now have notify user instead of collect payment. So just ignore what was all on the previous slides. We've switched a little bit. So, but same thing. We got 4 actions that are going to occur in sequence. These individual functions are just again kind of normal TypeScript functions. Actually, I'll go into my activities. I'm just mocking this out, but imagine my book flight function could do whatever it wants. It could write the reservation to a database. It could call out to American Airlines API, whatever that might be. This is just a normal TypeScript function, as with book hotel, as with book car. So I have some simulation code in here and code that will help me with other demo scenarios. But this is the core, right? We're talking, I got some comments in here, and we'll come back to these in a second. But really, in our orchestration function, our workflow function, 1, 2, 3, 4, 5 lines of code, right, in terms of what we're executing. Let's go run this. All right, so here is my trip booking application. My apologies for the half of you who are not back-end developers, because you're all front-end developers, and you're like, this is awful. My front-end skills are from 2003. So yeah, not great, but bear with me as I'm more focused on the back-end here. So we're just going to go and do a standard execution of this booking. But actually, before I click the button there, I do want to just show the temporal service in the backend. So this is my temporal service. This is the thing that tracks execution of the workflows. And we're going to get to your question about how does it know where progress is, what has succeeded, what has failed, and how we recover for that. So that's going to be in the concept of a workflow on the temporal service. And so we're going to see this light up. Information goes into this as we go. So I'm going to click that book trip function or button, and now we see a workflow showed up in the temporal UI. And so this workflow is now it is quickly executed in 6 seconds here with some of my synthetic sleep statements to slow it down. But the 4 primary subfunctions or steps or activities of this business process is executed book flight. It is executed book hotel, book car, and ultimately notify user. And so the very first thing I just want to call attention to is the great visibility we get into the execution of our function, right? Some of those challenges, again, highlighted by Amazon and Azure and Microsoft, was sagas and complex workflow patterns are hard because, particularly in like choreographed environments, because you don't have a central view of where that function is, what is happening, and how that function is executed. And you get that immediately with Temporal, because despite the simplicity of this coding model, each of these functions, because this is in a temporal workflow function, it is defined as a temporal activity function, each of these functions is now orchestrated and its state is managed and preserved by the temporal service. So in addition to just the colorful lines that we see in the event history, we can actually dig into what some of these things look like. Our activity function, or the events related to the execution of activity function in temporal, again, store the state of this function execution. It stores, again, the name of the function that was executed, the inputs that were provided to the function, if the function completed successfully, the result of this function. All right, and so we get all this rich event history, and obviously we can graph it and visualize it in the chart. But this is going to be super useful once failures start to come into play. And so let's do that. Let's introduce our very first failure of execution into this environment. I'm going to go here, and I'm going to book my trip again, or check the book trip function. And now I'm intentionally going to crash my application. So I had a process that was running. We saw some log statements start to spit out here. But then I did a hard crash, a control C of this application process. I have no more application running within my laptop here, or anywhere else for that matter. Nothing on my sleeve. So this application on the left-hand side is dead. But we saw some hints from logging that it had made progress. Some things had happened, and while that progress was being made, it was being stored in the temporal service. And so let's take a look at the temporal service. What is in there at this point in time? We'll jump back up to the top level view of our workflows. We see a second workflow has been started. And this workflow, from a temporal perspective, is running, right? The function has not completed. Temporal guarantees that a function is going to run to completion with consistency. There's no process that's running any code related to this function at this point in time. But there was a process that did run some code, and it executed book flight, and it executed book hotel. And now there is another task that needs to be run. And this is a workflow function task that needs to be run in order to figure out what needs to happen next. And Temporal says, great, I'm just going to put a task out on a task queue. I'm going to schedule this task. So I'm telling some worker out there, when you are available, Mr. and Mrs. Worker, to pick up work, I have a task that is scheduled ready for you to pick up. So it holds on to the context of all the previous steps of this function execution, and now as soon as another process come online, it's going to be ready to pick that up. So we're going to go and we're going to start up a new node process here, and immediately we see from our logging, and we'll quickly verify in the code, that this process has picked up the function execution and moved forward with the next activity that it needed to process, which was booking a car. And so in our graph, we see a ton of white space, of course, in between book hotel and book car, and that was the entire time where there was nothing running. The application was dead, it had crashed. But the state of the steps that had happened prior to the crash were preserved. The new process picked up this function execution context from the temporal server. The server delivered the execution context and the history to that worker, and now that worker could resume that function from that point of failure and continue on with book car and notify user. So again, our function execution spanned process boundaries. It started on one process, that process died, it picked up on a second process, that process continued from the point of failure to completion. And that happened with me writing 5 lines of code. I didn't have to write any area in it, right? So that's the velocity aspect, the developer experience aspect of us writing this. Now, this whole presentation or the premise was around Sagas. You're like, where are Sagas coming into this play? I haven't seen anything related to Sagas yet. Let's get into that. So in this case, I have a scenario in my application where if I put in an invalid car, that's going to be a logical business condition, and the car booking will fail. So let's go ahead and book that trip. And we will see a new workflow spin up. And in this workflow, we'll execute book flight. We'll execute book hotel. It'll execute book car, but book car will fail because that is a type of invalid car. So now our distributed transaction is blown up, right? We've done 2 out of 3 things. This workflow, I ran it to completion, so it finished. But that is certainly not atomic, right? I haven't handled the compensating actions, right? I haven't executed the undos related to the things that happened successfully. I need to return state back to where it was at the beginning to make that all or nothing that atomic. So what level of code do I need to write to do that with Temporal? Well, with Temporal, I'm going to introduce, and this is just standard TypeScript, not even Temporal at this point. I'm going to introduce an array that I'm going to call compensations. And it's going to hold structural members defined on this interface. It's going to have a message associated with it, and it's going to have a function to execute. Right? So I'm going to initialize this array as empty. Now, each time in my code where I execute an activity or a step, I'm going to store in my compensations array the reverse activity. right? So in this case, I'm going to unshift because I'm going to do these in reverse order. I'm going to put onto this array a function called undo flight. And it's just some pretty error messaging and handling for my message. Right? So I'm going to book a flight. And then if the book flight is successful, something may fail in the future. And if that thing fails in the future, I want to tell the application how to undo the book flight. So I'm going to store on my array a potential function to execute called undo book flight. I'm going to do the same thing for booking the hotel. I'm going to shift onto the array or unshift onto the array the compensating action, the reverse action for booking a hotel. If book hotel is successful and something fails in the future in this program, then I want to handle that by executing the unbook operation. And finally, the same for booking the car. Notification doesn't have an undo operation there. Then if any error occurs along the way, in the catch clause for that error, I'm going to execute my compensating activities. And that's just done through a new TypeScript function here, where I'm going to just iterate over the length of this compensations array. And for each compensation within that array, I'm going to execute the compensating function. So this is my Saga implementation. Figma, no queues, no databases, no external state management, none of the complexity, again, that we were warned about from Amazon, from Microsoft, from Azure, around how hard Sagas are to implement in modern microservices application. All right, let's save this code. I'm going to go ahead and restart my worker application. We're going to go back to our trip booking. We're going to put that invalid car back into our UI. We're going to see this function or this workflow show up in Temporal. And now at the point where we hit book car, this is throwing an error. This error is going to be caught by our catch clause in our function. So this error is thrown. That application error is caught by the clause. And then the clause triggers the compensations that are now in our compensation list, right? That have been stacked onto that array. And therefore, it's going to execute those in reverse order, right? The hotel was booked. We got to clean that up. We got to unbook the hotel. That flight was booked. We got to clean that up. We have to undo that flight booking. And we've now successfully returned the state of our system back to the original state. That atomic property of all or nothing has successfully been applied to this distributed transaction, despite the fact that we didn't have a single database to help us. We had to write a little bit more code, but Temporal gave us the power to do this with a simple programming model and with guaranteed reliability. All right, that is the core of the demo. Any questions on that? Yeah.
So how does this maintain state under the hood to achieve this durability? Is it like a process level, or is it doing any code analysis of the functions?
Everything, yeah, so great question. So the question was, how is state maintained and actually kind of tracked by the server? Okay, so this book flight is a standard TypeScript function, right? I go over to my activity files, and this is just general TypeScript, right? There's no Temporal specific SDK code as part of this function. I can write whatever I want in JavaScript TypeScript flows. However, when I import this function into my workflow, I create in Temporal a function proxy, and this is part of the Temporal SDK, right? So Temporal is actually the SDK is putting a wrapper around this function. So while from our perspective, in our workflow code, our programming model allows us to feel like we're just invoking a local function. We're not actually at all. That's part of the magic of Temporal. We're invoking a Temporal proxy function. And so that proxy function is obviously running within this process, but now it is shipping the event up to the server to tell the server, all right, that a function called book flight needs to be run. And so the server records the intent to run this function in its event history. Let's scroll down. And so we can see there's like this activity called or this event in the event history called an activity task has been scheduled. So the server is now aware that a book flight activity needs to run. It schedules that task on a task queue, and this is where its scheduling allows distribution to come into play. I could have multiple workers running. Any of them could pick up this function. In my example, I'm just running one worker on my machine. But now a worker has picked up this function, and it has started this function, and it records that event in the history. And then when the function is completed, again, this is all based upon the proxy nature of that wrapper, it returns this result back to the history. So this is an event-sourced model, right? Everything that happens in this function is stored in the event history, and that is what gives us the state of the world in terms of this function execution. If something fails, we can recreate the state by reprocessing the event history. We know everything that's happened in the past, and we resume from that point of failure on forward. Question in the back.
Yeah, as far as retries, is there a limit? Does it retry a step a couple of times? Can you configure it to retry a step a couple of times before rolling back?
Yep. Great question. The question was, how do retries work? Are they configurable? Are there limits? What is the approach to use them? Yes. So every function that we import and we proxy has an associated retry policy out of the box for it. And we have all kinds of configurable options to our retry policy. We can set how many times we want to try, the maximum number of attempts, the interval between attempts, how much we want to back off. So in this case, my initial interval for retries is 1 second. My backoff coefficient is 2, so it's going to go 1 second, 2 second, 4 second, 8 second, etc. This retry policy will try to infinity, but you can set a maximum number of attempts as well. There's also the idea in Temporal of retriable errors and non-retriable errors, right? Transient failures, you want to retry, right? If there's a network blip in your environment, you don't want to handle that error, you just want Temporal to retry it. If your database is temporarily offline, again, don't let your function fail, let Temporal just continue to try that operation. But if somebody has a business level, logical condition that is failing, and in this case, I've coded that into like my book car function. If I'm trying to actually book an invalid car, which doesn't exist, there's no sense in retrying that. The car will never exist, right? It's an invalid car. And so in this case, I explicitly throw a non-retriable error for my temporal function because I don't want to retry this. I want the main workflow orchestration function now to handle what to do. And that what to do is to catch that exception and invoke my compensating activities.
So thanks for introducing this library. I was looking for something. I only know Celery in Python.
Yeah,
that's very similar. One question. So as a message broker on the backend side, does Temporal support queues in AWS, or does it have its own message broker?
Yeah. So there was two comments there. One was the gentleman has used Celery in Python, which is like a task execution framework, right? We have a Python SDK. I work with folks that are migrating from Celery to Temporal often as my job as solution architect. So there are reliability and durability challenges with Celery that still cause a lot of pain for developers that Temporal can help with. The second is Temporal's queuing implementation, like what does it use on the back end? Is it configurable? Does it differ across clouds like AWS specific implementations versus others? We have the concept of a task queue for sure, but our implementation is in a database. It's a persistent store. So we don't actually use Kafka or SQS or Rabbit or any other type of traditional message queuing. The semantics of our task queue are, you can think of it for all intents and purposes as a message broker. You're not dealing with, as a developer, reading and writing the messages themselves, right? When you call book hotel, and book hotel is a proxied function, it is automatically sending messages up to the server to preserve the state and retrieving tasks off the task queue to execute that, right? So that type of messaging is just happening transparently, and that's the benefit, the beauty of not having to code this. I don't have to worry about using message queues for asynchronous message processing to achieve scalability or availability in my environment. Temporal handles all that for me through the SDK. So I get to focus on my business logic, simplify my programming model, and it handles it in the back end. But it is a temporal specific implementation of how the queue is managed and exposed to the SDK. follow-up question?
One follow-up. So can the workers be on Azure functions or AWS Lambda functions?
So the question was, can the workers run as AWS Lambda functions? At this point, no. So the worker processes do need to be long-running processes because in our current implementation, they long poll against the server. So when this application starts up using the Temporal SDK, it establishes a long polling connection to the Temporal service, and now it's listening on that task queue, or it's constantly pulling that task queue for work. And so we are experimenting. The team has played around with other eventing models that could trigger a Lambda as a response to this, but at the moment, you're going to be looking at implementing or running your worker as ECS container, EKS container, AKS container, something like that. Yeah.
I think I have something related question. Is it possible to implement some kind of middleware in Temporal and to listen for, in the try catch and try section, as I remember, and add some service, third-party service, which will take our log of errors or whatever happens with our application and wait for response, play according to that response next phase.
Yeah, the question is, can you introduce additional middleware and error handling and logging libraries as part of your catch clause implementation to either notify or respond to this failure in another way? Absolutely, right? This is just pure TypeScript code at this point, or Python or Java or Go or .NET or whatever language you're coding in. So yes, I can use whatever my favorite logging libraries, middleware libraries are. Now, if I'm interacting with an external system and I want that execution to be durable and retried, I'm going to wrap that function in an activity, right? So now I'm going to create another activity function that calls my external system to send that message out to there. Even if it's now like more of an alerting or monitoring function, I'm still going to interact with that external system as an activity because, I want the reliability guarantee of delivering that message in that activity being
You will do kind of chain wrapped of the function. Yes, so you will.
Yeah, absolutely. You can build. Yes. So in this scenario, I've obviously depicted, just for demonstration and simplicity purposes, 4 functions running in sequence, right? Without any conditional logic in between them, right? But you absolutely can introduce any conditional logic you want in your function. If conditionals, looping conditionals, switch statements, case statements. Obviously, we're doing try catch here. I could do these in parallel. I could fan out and run. I could have run flight, hotel, and car at the exact same time as 3 concurrent activities and waited for the aggregate response for them. All of your standard, programming approaches and models, whether you're doing synchronous, asynchronous, you're calling external APIs, it all applies to Temporal. You're writing code, right? And we're just handling the hard parts in the background. In the back. Yep. Sure. The question is Temporal similar to Amazon step functions or AWS step functions, and what are some of the differences between them? Absolutely. So one, just a history lesson. Our co-founder, one of our co-founders and our current CTO, Maxime Fatif, was at Amazon. He built simple workflow service when he was at Amazon. That is the foundational of Amazon step functions. So there's a lot of shared DNA between step functions and Temporal. The primary difference with step functions is you are orchestrating your business logic in JSON, in a DSL specification, a schema that uses JSON syntax, right? You're writing a declarative format to program and code that logic. Temporal, you're writing code, right? We find that developers are much more comfortable in their IDE writing code, writing and debugging TypeScript, Java, Go, whatever it might be, in their language of choice, rather than trying to work in some bespoke file format, right, that they're not used to. Obviously, step functions is AWS specific. It's not cloud agnostic. It's not portable off other clouds. There are some nuances around performance and scalability of step functions as well. I won't get into the full competitive comparison, but happy to follow up with you if that's of interest. Question in the back.
It's okay if the answers you can't tell me.
Where
They don't run in lambdas. Where do they run?
Oh, your workers? Yeah, wherever you want, right? Other than Lambda, right? So this is just an application I built with the Temporal SDK. I can build, run, and code, can package this as a binary, deploy it on a physical machine, a virtual machine. I can package it as a container, run it in Docker, run it in Kubernetes. You are in control of where this runs. the only requirement is it needs to be a long running process. Like once you start this process, it should remain running, right? Versus a Lambda, which has a short lifetime, right? Which is designed to start up, execute a function, and then kill, and then die, right? This is going to start up, execute a function, it's going to keep running, right? And execute more functions and different workflows and other things in parallel.
Can't do the push pull in the Lambda without racking up a build. Makes
Yeah,
sense.
yeah. All the way in the back, there's. Can you repeat it?
He asked if all the parameters that are passed to a function have to be serializable.
Correct.
Or if he has to
Yeah, the question was, do function parameters need to be serializable? And the answer is yes, because everything is stored in the event history. So the SDK, when it writes that event, the event history, it serializes the parameters into JSON, and then it stores it in the server.
Yeah, if I understand well, during this demonstrations, you use an array. How will you demonstrate if you are using like a database or other?
Yeah, so in this case, I short-circuited like the real implementations of these functions like book flight or book hotel, right? I'm just doing a synthetic sleep here to indicate, this would be, simulating an external operation. So in a real world, this is where I would, persist a record to a database, or alternatively, call American Airlines API, right? So your external operations are going to happen in what's called the activity function, right? This is the function that again is kind of proxied into the workflow, and activity functions have automatic retries. So if there's a temporary issue with the database or the API you're calling, you automatically retry. But once the function succeeds, its state is automatically written to the temporal event history. So that also gives us the ability to not have to repeat that function when we resume the overall workflow function on a different process, right? Remember, function execution can span process boundaries. So we start a function on one process and it fails, we preserve all the work that's already been done, right? But yeah, when you're interacting with external systems and entities, you do that from within the activity context, so that both the inputs and the results of that execution can be saved in the event history, and you never have to repeat that work despite other failures that might go on.
How tricky is it to host your own temporal, like not use temporal
Yeah.
cloud and just build a scalable solution on your
Yeah,
own?
so the question is, how hard is it to host your own temporal? And you said it, not me, temporal cloud. So this is not a sales pitch. There is a thing called temporal cloud where this is how our company makes money. Is we host the service as a managed SaaS offering for you, right? So this backend. But we're 100% committed to the open source. Now, all the code we write, that goes into the open source is what runs on Temporal Cloud. So it's the same code that's running whether you self-host it or a Temporal Cloud. We obviously have some goodies in terms of, like a lot of vendors, enterprise security features and things of that nature that you might want to check out. But how hard is it to run? I mean, it really depends upon like your operations team. I mean, how hard do your teams find it to run a Kubernetes cluster, right? Or how hard do you stand up other self-hosted infrastructure? The temporal service is a set of 4 components, 4 microservices that are independently horizontally scalable. There's a Helm chart that helps you deploy them all to a Kubernetes cluster. The hardest part probably of running your temporal service is choosing and maintaining your persistence layer. So the temporal service does, again, store state, and ultimately all the stuff is written to a persistence store. We support MySQL, Postgres, or Cassandra out of the box. They're each going to give you different levels of scalability and performance. So you got to choose the one that works, for you the best. You got to kind of do that homework and due diligence to figure out, what level do I need? What is your in-house expertise as? Like, have you anybody in your team ever touched Cassandra, or is that like completely foreign to folks? Or are you more familiar with MySQL and Postgres? So there's a number of decisions. We do have collateral out on the website, that obviously, helps and guides you to set up a self-hosted cluster. I'll say Temporal Cloud, we have over 2,000 customers on Temporal Cloud. At our last count from like our community, there's like over 200,000 developers in the community. Now that doesn't mean everybody's running like a full-blown self-hosted cluster in production, but the community, the open source community is certainly way bigger than a cloud. So there's plenty of people out there that are running their self-hosted clusters. They're active on the community forums. They're active in our Slack channels and community there, helping each other out, around running self-hosted.
One follow-up question. So metrics and alarms. Suppose I'm using Temporal. Can I hook it up to AWS metrics and alarms, or do you guys have your own dashboarding, alarming?
Yeah, no. So the question was, when running Temporal, what's the story around observability and metrics of the service itself? There's two sides to metrics. There's metrics that the SDK emits as the workers execute, and there's metrics that the service emits. SDK metrics for every language can be emitted in either Prometheus format or OpenTelemetry format. So whatever you're using, you can integrate with that. On the Temporal service side, we emit Prometheus metrics. And so if you're using Prometheus or Grafana, it's easy plug-in. If you're using something else, there's adapter layers and layers probably that consume those metrics.
Seems like it's similar to BPNM in activity command.
Sure.
So does it, given like a BPNM file, can it, is there a translator to convert it to like a temporal application?
Sure. Yeah, the question was, the gentleman sees similarities to BPMN, a business process modeling notation, and vendor solutions and commercial solutions that implement BPMN specifications like Camunda. In those solutions, the way you define your business process, the way you define your workflow is through a modeling tool. Right? They give you a visual designer that ultimately generates XML, and that is your BPMN model. Can Temporal consume that model and run that? The answer is no. We're 100% code first. Like we don't. Again, similar to the step functions question, like step functions is a visual designer that generates JSON, or developers are going in and manually modifying JSON files to separate their activities. I'll be blunt, it sucks as a development process. It's great for some people, some persona and maybe business analyst or somebody likes that. But as a developer, we're 100% focused on giving developers the power of code.
Does it have like all the gateways, asynchronous, synchronous gateways, all those components?
All can be done in the SDK code. Yep, absolutely. There's no pattern that Camunda or any modeling interface can do that Temporal can't. In fact, probably the opposite is true because they're giving you a constrained language, right? Around like their modeling UI only gives you certain options to choose from in terms of what the steps of your process can be.
Sorry, but the latest Camunda, they have a Fluent API, so you can design your application with in Java itself.
Yeah, the response back was Camunda also provides a Fluent API that allows Java code. It's still a DSL though, right? They give you a Camunda if primitive, right? Like you're familiar with the Camunda code. So if you want to write an if condition in Camunda, you're not using a Java if. It's Java code, but they're giving you on a Camunda object a method called if, right? Like you have to learn their language, right, in order to do it. You don't with Temporal. You write Java code or TypeScript code or whatever your native language is. You use if, switch, looping. You're not learning a different domain-specific language, even though, like Camunda, you could argue like whatever it's domain or not, but you're just writing Java code at the end of the day, right? And your editors and your IDEs and your tooling, everything that supports understanding Java or TypeScript or whatever language it is, just works, right? You don't need additional tooling to get it done. I'm way over time. I'm probably pissing people off for all this. I know there are questions in chat, and I don't want to ignore the remote folks. So Pete asks, what happens if compensation logic also fails? Would your transaction be in limbo? Do you have a queue or retry logic as well? So there's absolutely retry logic. We kind of talked about that before. You can set infinite retries on all these operations. So this becomes now a design question to you. Like from a business process perspective, what do you want to do? If this is something that in your general pattern of execution you think is recoverable, then let Temporal just retry and don't worry about it at all. If you hit a scenario that is unrecoverable, well, then you could always fall back to what you do today. That was kind of the question that the other gentleman in blue asked, like, can I now integrate with an alerting or monitoring system? Can I send an event or message someplace else, maybe for somebody to manually review? Our goal with Temporal is to get people out of manual operations, right? Like let the system retry, let the system progress, let the system roll back, let's automate it all and codify it all. But yeah, at the end of the day, if there's something that simply just cannot be resolved without a human interacting, send a message to an alerting console and let the human pick up the message and figure out what to do next. Where does the queue get stored and run? I think I answered that. The queue is on the temporal service, and the service implements the queue as a database, but it's proprietary. It's not like a standard queue. Are there external dependencies, Clayton? Yes, you choose a database, MySQL, Postgres, or Cassandra. That's your primary external dependency for temporal. Additional advantages provide likes of Kafka and RabbitMQ. That's a rabbit hole, and again, I'm way over time. So reach out to me on LinkedIn, Pete, and we can take that to a thread around the comparison between.
Hey everybody, so who uses Figma here? Awesome. All right, cool. So what I want to show is how your front-end teams and design teams can work in harmony with a little tool that we've been working on at Bitovi, a new open source project. We're calling it Extractor. Essentially, anybody use a Figma, the CSS tool right now to extract CSS from the Figma?
Dev mode?
Yeah. Well, besides dev mode, that's a good build. Yeah. Anybody use one of the native or like one of their plugins? Or just dev mode people are using? Okay, so the reason there's a bunch of other CSS generators on the market, but ours is a little bit different, that it just exports mixins for you as engineers to use. So you can orchestrate and design your CSS to match whatever your needs are. So I'm going to show this quick little demo here. So I'm not a designer, so don't judge what these form controls look like. But I've implemented a little input with different different variants. You know, those familiar with Figma kind of know what's going on. Let's say I do not like the looks of this label. This is first of all, this is the resting state. This is the hover state, and this is the active state. Let's say I don't like what that label looks like. The text there, I want to make it a bit darker. So I'm going to change the color of that to dark blue. I'm going to then open up our new plugin we made. This is already configured with my Figma token, the project that I'm working on, where I want the mixins, the SAS mixins, to be placed in my project or where they already are. And then I'm going to make a PR. I'm going to name my branch here blue. I'm going to generate the mixins, and I'll talk about what these look like in a moment. Create a PR. Now this will create the PR. Now I'm going to give this a second. So this is also going to build and do it's going to build the project and do a deployment for that branch. So if I'm the designer, once this runs, I'll actually be able to see my changes live. So I can just change things in Figma and see it live. This will take a minute as it's spinning up here. But I want to show what it's while it's taking its time. I'll show what it's writing out here. So again, this is the mixin. This is basically the provided mixin, just a bunch of functions of CSS properties. So for like our resting state, here's all the mixins that make that up for all the CSS properties. For the label, here's the CSS properties, so on and so forth. You can kind of see for everything in Figma in here, as long as you've named these nice, it will generate a mixin for you. So then my CSS becomes very simple. I'm just aligning those mixins with how I'm structuring my HTML and my CSS. So I have a custom input element, and that's going to have a label and an input inside of it. And then when it's hovered, I want the label to have the label styles and the input to have the hover input styles. And when the outer contain has focus inside of it, I want its input and label to be styled appropriately from what Figma is exporting for us. So hopefully by now my build is done. Click the link, and I can see that it turns that dark blue now. So this is, I think, pretty cool way of working, right? Thank you. So this is a new plugin for us that we're about to like open source and make. It is already open source, but it's not in like Figma's plugins. You have to like kind of get it, build it yourself right now. But let me talk about just why this might be interesting to you. First, instead of trying to guess at like the final CSS structure and HTML structure which you might be using, we don't do that. That's like too hard of a problem to solve. We just give you the mixins. Also, because we're giving mixins, it just means you're only really using the CSS that we're exporting that like you actually are linking to. So it keeps your final CSS build small. For the developer, if you want to implement with like semantic or like is it, do people say BEM or BEM or behavior element or behavior
Block element
modifier? Whatever approach you're using, it doesn't matter. You can just use your mixins for your approach. And the other thing, this supports Figma variables, which is a new feature in Figma that lets you kind of like have your maintain your atomic consistency. So people can't just arbitrarily use like 3 pixels. They have to use 2 pixels or 5 pixels or 10 pixels. And not all of the other plugins support this yet. So next steps to releasing this, we're working towards getting full CSS property support, everything Figma supports. We can write out correctly. When we do write out, we write out correctly, but we don't write everything out yet. We're looking for pilot work. So if you're in a organization that'd be like, wow, this would be really cool to use, hit me up. Again, this is open source. We're just trying to find people who might be interested in using it. And after the MVP, we're going to try to make a design system that actually uses this. So like the first design system where you can just change stuff in Figma and generates everything and updates your styles automatically. And then we want to make it work with other things than Sass. So it's at Bitovi/extractor. You have been an excellent audience. Thank you for listening to me. And if you want to reach out to me, QR code Justin at Bitovi and on LinkedIn. So thank you.
Hello, everybody. Thank you all again for coming and for staying so long. I'm really excited to talk to you all today about using Temporal to build better applications on top of AI tools. My name is Kevin Phillips. I am the Director of Backend Development at Bitovi. As Heather mentioned at the beginning, we are a software and product development consulting company, and we are focused on helping our clients perfect their applications. Today, I'm going to talk about building applications on top of generative AI technology, like large language models and AI agents. I'm sure you've all seen the huge growth in this space. Let's do a quick poll. How many people are building apps on top of LLMs or other Gen AI tools today? So for those of you that didn't raise your hand, hopefully this conversation will help prepare you for that day. Inevitable day when you are asked to build something on top of AI. And for those of you that did raise your hand, you probably already know building applications on top of AI can be really challenging. These systems have lots of external dependencies, and inherently there's just a lot of things that can go wrong. Let's take a look at a typical AI application architecture and all the things that can fail. I'm going to talk about a very simple application, a custom AI chatbot. So this is an AI chatbot that has some sort of context about your business. This example is going to use a technique called retrieval augmented generation, or RAG. So before we walk through this, let's take a minute to understand what that is. Again, RAG means retrieval augmented generation. Before we get into what it is, why is RAG? Why do we need to use this? So there's tons of great general purpose LLMs that exist today, like GPT-4 from OpenAI and Claude from Anthropic, and there's 10 of them. These are really good at answering general purpose questions, but they're not great at answering questions about your business or whatever your chatbot is meant to answer questions about. So back to what is RAG? RAG is a technique for querying these general purpose LLMs while giving them context about your business. So providing them external information like your internal documents and things like that, so that they can answer specific questions for your own. So without RAG, this is ChatGPT. You ask it a question, it gives you back a general answer based on its training. With RAG, you see, you pass in your question along with kind of some background information that the LLM can use when it's answering. It'll give you that optimized response for your business, your use case. So, quick overview of how RAG works. We want to pass information that's relevant to our user's query to the LLM. To do this, we need to know what information is relevant to the user's query. One option would be to just send all of the information that we have. There's a ton of reasons why you don't want to do this. One is LLMs have what's called a context limit, which means you can only pass it a certain amount of text in all your questions. The next is money. They often charge you based on the length of the query that you're sending. You send in more information, that costs you more money. Lastly, it's often just impossible. You might have thousands or hundreds of thousands or millions of documents that you might want your chatbot to rely on. And it would just be impossible to send all of that. All of your requests would take 10 days or something. If you're an insurance company building a chatbot for your customer service reps, that you want them to be able to ask questions about all of your policies. How many pages and pages of policies do you have in the company? There's no way you can pass all of that information. So instead of sending everything, the common technique is to store that data in what's called a vectorized representation. So you can see this black box in the middle, this vector data. These vectors are just huge arrays of numbers. In this example, it's like each one is 1,024 numbers. These are just mathematical versions of the text that's within your documents. What this allows you to do down here at the bottom is when your user's query comes in, you can create a vectorized version of that, and then you can do a search of your data to say this vector, which vectors are most similar to it, which data is most related to my user's question. Then you can provide that query along with the background information to the LLM, and it has that information drawn. Okay, so coming back to our example, our AI chatbot that's using RAG. I have this broken down into two workflows just for the kind of purposes of talking about it. Workflow 1 is responsible for document processing and building up a RAG database, and workflow 2 is responsible for handling the user's queries. We'll walk through each half. So workflow 1, like I said, this is responsible for creating our vectorized knowledge base. It takes in our internal information. Maybe this is our company's wiki, maybe it's source code repositories, chat data, our PDFs of our policies, whatever it is that is the background context for your application. Then archives that application here in the middle. These things change, and we want to know when we created our vectors, what was the actual version of that file that existed. It then creates a vectorized representation of the documents. So this is using an AI model that's specifically designed to create these huge arrays of numbers. And then it stores it into our database. Workflow 2, this is responsible for handling our users' queries. The query comes in, runs that similarity search to figure out which documents are most related to this question. Then it passes that query along with that additional context to the LLM. And we get back our optimized answer for that query. So let's look at all of the things that can go wrong in this architecture. Anybody want to take a guess? What is something that can fail in this architecture?
Your database.
Vector database, that's a good one. What else? Yeah.
The vectorization process could be an imperfect representation of your documents.
That's a good one. I'm not going to cover that, but that's a good idea. I'll just go through it. So our background data, this is all, we're probably going to access this over APIs. So you're going to use an API to pull the data from your wiki, use an API to get the data from your source code, to get your PDFs from wherever those are stored. These APIs obviously can fail for a bunch of reasons. Maybe they're rate limited, or have access restrictions, or your network goes down intermittently, something like that. Our S3 bucket, or whatever we're using for archiving our data, that's another API that can fail. Peter mentioned the vector database. Databases, go out, database contention. Say you have a million users that want to use your chatbot, you can run into issues like contention. Again, network issues is really a problem for all of them. And then lastly, on this, the LLMs themselves. All of these LLMs have pretty strict rate limits. OpenAI's is like per minute. You can send it, X amount of tokens or whatever. So these can fail. Again, they can fail for all the other reasons too, network issues and things like that. This is where Temporal busts in to solve our problems. the durable execution stuff that Peter explained earlier really helps prevent these issues from breaking our workflow. All right, let's get to the fun part and see a demo. We'll share my whole screen. All right, so I'm going to demo this application called the Temporal AI Code Analyzer. What this is designed to do is to look at a source code repository and be able to answer questions about it. So first, for the demo, we need some source code to look at. I just heard about a really cool project called Extractor. Not just to show because Justin's my boss, but I've seen that before. So we can use that. So I can run my analyze workflow. I can type. I can give it my repo, and then a question. Say like, what is this? Before we run that, let's go ahead and open up Temporal's UI so we can watch it as it executes, and then we will talk through what's happening. All right, so we should see our workflow pop up here in a second. All right, and we can watch it as it runs. Awesome, and then we get back answer that's prettier printed over here and says it supports these properties. Is that accurate? I don't actually know. Pretty good. Pretty close. Okay, cool. So let's take a look at what happened here. So as Peter mentioned, Temporal is an event source system, so their UI gives you a bunch of different ways of viewing the event history. At the bottom here, you get this all view that shows you the floodgate, all of the things that happen to make this work. Compact view is a little bit nicer. It consolidates things, all the events that are related to the same function. So for example, our create S3 bucket function here, there's 3 events that happened as a part of calling that function. The task was scheduled, the task started, the task completed. Also at the top, we get this cool timeline view that shows us kind of what happened in what order and kind of the relative amount of time each thing took, which is nice. So let's walk through what all happened to make this work. So first thing we did was create our S3 bucket. That could be our long-term archive. In my example, it's just temporary storage for these files. Each workflow downloads everything and starts from scratch. If you're building this for real, you wouldn't want to do that, but makes the demo nicer. The next thing we do is archive that repository. So this finds all of the documentation and source code and adds it to that S3 bucket. Then if we look at our timeline view, the next thing we do is call this get embedding data function. It calls it once for each file, running in parallel. So you can see they all kind of kick off at the same time. We look at that. What that's doing is calling out to OpenAI's embeddings model that we're using and generating this huge array of numbers here. This is the next thing we do is call this insert embedding, which is putting it into our RAG database. You can open up the database and we can take a look at the data. So you can see that. All right, so here we have all the registries, the source code and documentation files from that repo. We've got the key, which is just kind of the path to that file. The actual content is stored here. Like I was saying, in a real application, you'd probably just want to store this in your long-term archive. Your files might be much bigger than this, but for demo purposes, it's a little easier to see it here. And then we have the embeddings data, just huge arrays of numbers that all look kind of the same, but aren't really. So the next thing we do is some cleanup. I'm deleting those files from S3 every time. And then after that, we call get related documents. So we take the user's query and we create a vector out of that. And then we query against our database to figure out which files are most related to that question. And we get back kind of some code, more code. I assume the README is in here somewhere. Anyway, we get back some. Get back some files that are related, and then we call our invoke prompt function, which is doing that RAG. So let's take a look at the code for that, so it's a little easier to understand what's going on there. So in our invoke prompt function, We give the LLM some background information. We say you're a software assistant, you're trying to help people understand this Git repository, give it some information about how it should respond so that it looks nice, things like that. And then we say, here are the files from the repository that are relevant to the user's question, and we just pass in that content as a big string, and then we pass in the user's query. So this is our RAG in place. We're not just sending the query directly to the LLM, we're passing in all of this content that is related. Cool, and then we get back our answer. So that's great, but in this example, everything worked. Everything worked successfully. The whole point of running this in Temporal is that it helps you when things go wrong. So let's run one more demo and see some failures. The first thing we can do is simulate a new production release. We got a new version of the code. We need to deploy it out to the server. We're going to check out that code. This has NodeMon running, I think, so it should start running. Yeah, cool. So our worker restarted when we changed the code. The next thing we can do is use a little bit of demo magic to create some synthetic errors with all of those external systems. So we use AWS for our S3 bucket, so we can cause some chaos with AWS. Don't worry, AWS is not actually being harmed in this. GitHub we use to clone the repo and pull all the files. Start some chaos with GitHub. OpenAI we use for the embeddings model and for the query at the end. And then lastly, our RAG database. We got all of our chaos started. We can go back and try this again and see what happens. Should see a new workflow pop up. Start. All right, so we're trying to create our S3 bucket. Should see failure here in a second, I would assume. Yes, it's magically working. All right, cool. So this bar turns red in the timeline. Down here at the bottom, we can see this big red line. Also up at the top, we can see pending activities, which gives us another view of these things. Anyway, lots of ways to see that this is failing. And we can dive in here and see exactly what's happening. We get back our error message and the stack trace that says, error getting an object from S3, AWS is totally down. That's not good. AWS should not go totally down. Say there was a temporary blip, maybe something in our network prevented us getting to AWS. AWS comes back up. We can see that our create S3 bucket function passed. Now it took 16 attempts, but it was successful. Now we try to archive our repository, and we get another error that says, are you sure you want to use GitHub? Weird error for GitHub to send, but we do want to use GitHub. Let's bring GitHub back up. See that already succeeded then on a retry. Now trying to get our embedding data. These are all failing at once. Something's going wrong. You can see that our OpenAI rate limit was reached. This is a real error message that I actually copied from delayed. Real error message that I copied from an actual time when we hit OpenAI's rate limit on a system like this. Yeah, OpenAI came back up. The next thing it's trying to do is insert the embeddings data into our database. And it says that the database is out to lunch back in 15 minutes. It's been 15 minutes, so should be able to finish. Let's see what happens. Now we get this giant red error at the top that says there's an unhandled error in the workflow itself. If we expand this, we can see the message says testing, remove before production release. And then it gives you the stack trace. We can see in our workflows file, there is something is going wrong on line 99. It's really big. Someone is throwing an error that says testing, remove before production release. So we could fix this and put out a new release. We can also roll back to our previous version. Restart, that's how we do a production release. Then we should be able to see. All right, we see it continued. But like Peter showed off earlier, Temporal already knows all the things that already happened. Doesn't have to go back and create a new S3 bucket, archive our code again, get the embeddings data. All of this stuff is already done. It can replay these events on top of our code and get back to the exact state that it was in when the process crashed. We just return back our response. So in this example, everything that could go wrong went wrong. All of our external services failed. Our own code was bad and crashed our server. And Temporal was able to finish this successfully. Yeah, that's all I got. Any questions?
Question. So like at the Toby, when you guys are using this, do you guys run this on like every single function you have out there all the time? Just to see if there's failures? Or maybe I don't know what my question is, but like
there's definitely places where Temporal fits, and you don't always need to use it. There's definitely places where you don't need it. So kind of comes on a client by client basis. We do consulting for clients, but it is useful in a lot more places than we would have thought originally. Anything that has these kinds of distributed transactions, anything that you need to succeed all the time is a good fit for Temporal. That's a lot of things.
I think we could share one place where the
we talked last year. We started using Temporal with Yum Brands for their kind of distributed order workflow for KFC, Taco Bell, Pizza Hut. So that's kind of similar to the workflow that we do. We've used it for a lot of other things too, infrastructure, tooling, things like that. You need your deployments to always have that. Lots of e-commerce, lots of different things.
I have two questions. One is that can we like add workers as we need and then remove workers as we need? Like is that something that can be done? Like is okay?
Yeah. You can auto scale your workers just like any other services. They are handling events. It's a distributed event-driven system, so you can have as many or as few workers as you need.
And the server itself, like so I have a lot of tasks to be done, and like different microservices submit a lot of tasks to the server. So single server is it like a single server or is it by itself? Can it be scaled? Like will it handle? What happens if the server itself fails?
Temporal server, you mean? Yeah. So I think Peter mentioned. So Temporal is kind of 4 services and a database. So if you're running Temporal self-hosted, you can auto scale those 4 services independently as you need. They designed it to be, horizontally scalable at each of those services. This is using Temporal Cloud. I am allowed to do this. Yeah.
What's the uptime on Temporal? Like what happens when they fail?
On Temporal Cloud?
Yeah.
I don't know. Ask
Yeah. Great question. So in theory, right, we've traded potentially, at least in my presentation, I talked about an orchestrator as a single point of failure, and now Temporal, right? So it's totally reasonable to say like, all right, is Temporal my single point of failure? We run the Temporal service with a service level objective of 99.995. We guarantee 4 nines for a Temporal Cloud namespace. So there's no guarantee, there's no 100% uptime or availability for anything, but we actually have we have a status page like a lot of other SaaS companies with a status page. You can go check it out yourself. But yeah, the availability is historically over 4 nines.
And if you're running Temporal self-hosted, it's like anything else you're running on Kubernetes.
Yeah.
As good as you are at Kubernetes.
We have one question from the virtual audience. Jessica asks, when this works well, what's the impact on the latency or response time?
That's a good question that, again, maybe I can throw it to Peter, but there's definitely, there is some latency, right? You're sending commands to another service instead of running a function directly. There's going to be some latency. If you're running like a 3D game or something, maybe this isn't the best fit. I don't know if you have numbers off the top of your head.
Yeah, so so each one of those events in the event history persists something in Temporal Cloud, or in Kevin's case, and Temporal local server in my demo. So there's network plus persistence latency. On Temporal Cloud, each operation probably averages around 20 to 30 milliseconds per operation. So you can think if you if you have 5-step operation, you're incurring 150, 200 milliseconds of latency in your end-to-end business process. But yeah, you're trading that for durability and reliability there. So it's Temporal is not used in like high frequency algorithmic trading, right? There are certain like use cases that measure latency in microseconds or even nanoseconds. That Temporal is not going to play in that at all. We're talking tens of milliseconds, in the range of 10 to 100 milliseconds of additional latency for what you're doing.
Yeah.
I know you have a demo in other languages, Python or something else. Just more generally though, your just the state of AI development across languages. How was that? Were there any challenges in like the right libraries for TypeScript or it's this demo or other work you've done around AI versus like what language, maybe corollary, what language you choose for an AI application?
Yeah, that's a good question. A lot of people that are building AI tools choose Python because a lot of historically machine learning and natural language operations are done in Python. I think if you are building an application like this, where you are building on top of Gen AI tools, I think the choice of language matters a little bit less. It kind of comes back to whatever language your team is most productive in. I originally wrote this in Go when I did it the first time, just because that's the language I am using the most often right now. And then we converted it to TypeScript, and both are fine. At least with OpenAI and things like that. There's lots of tools. We use LangChain, LangChain is available in lots of languages. But yeah, a lot of people choose Python. I think Python and Go are probably the two most the people that I've talked to.
Dorch, if you're building your own neural network and your favorite HTTPS REST library, if you're calling ChatGPT. So
if you're building your own neural network or you're doing your own machine learning, Python is the thing people use most.